Alright, so in this video we're going to look at factoring quadratic trinomials using the AC method. In a previous lesson, in 9.5, we factored cubic polynomials by grouping, where we're going to use that technique of factoring to factor quadratic trinomials. Okay, so take a brief moment and find each product first. I think it's a good idea to know how we got to these polynomials so that it can kind of help us figure out how to get to those factor pairs. So go ahead and take some time and multiply these products out. I'm going to do each in a different method. If you do all three in a particular method, so like if you use the box method, or you use the distributive property, or you draw your little distribution arrows, then that's fine. But I'm going to do each in three different ways. So go ahead and pause the video and work on those three as a warm-up. All right, so I'm about to reveal the solutions to each problem so you can confirm your answers. So for number one, okay, here we go. It looks messy, but I used the box method for this one, in which you can use this for all three. But the box method works really well for those who need it like more visually organized. And you just multiply rows times columns. So x times ax gave me ax squared, right? And then you just keep multiplying rows times columns, and there we go. For number two, using distributive property like formally, okay, everything inside one of those binomials, one side of those, in one set of those parentheses gets multiplied by everything in the other set of parentheses. So, I took a minus 7, multiplied 3a times it. Took negative 4, multiplied a minus 7 by it. Or multiplied it by a minus 7. And then we just distribute again. So then 3a, everything inside a minus 7 gets multiplied by 3a. So 3a times a, 3a times negative 7. And then same thing with the other set. Okay, so you just rinse and repeat until there's no more distribution. Simplify, combine like terms. And then for number three, okay, this is what I meant by distribution arrows, or as some call it, the crab claw or the scorpion claw, okay? Or some might even say foil, but it works too, okay? So, p times 2p gave me p times 2p, which is 2p squared. And then you just follow that for the other arrows. Okay, p times 8, negative 1 times 8, negative 1 times 2p. Okay. And then you combine like terms, and you're done. So, there we go. Now let's actually get into factoring. Okay, so each of those polynomials are of the form ax squared plus bx plus c. This is standard form for quadratic, so recognize this. Okay. Standard form for quadratics is like this. All right, so to factor a quadratic trinomial, that's what we're doing today. Okay, and it says off to the left where a is greater than 1, but truthfully, even if our quadratic looks like x squared plus something x plus c, okay, a is still there, it's just a is 1, right? So you can apply what I'm going to show you to pretty much any quadratic trinomial that can be factored. Let me just take that back. You can apply this to any quadratic trinomial that can be factored. Okay, so check the form. Okay, 1, it has to be a trinomial, and it must be a quadratic. The degree must be 2. Okay, and we should factor out any GCFs. So 3, negative 10, 8, they have no common factor other than 1. So the greatest common factor is gone. So the first thing we're going to do is multiply a and c. Okay, so looking at our standard form quadratic here, A is 3 and C is -8. So AC could be 3 times -8, right? Which is -24. So it says multiply AC and list its factor pairs. So what are the factor pairs of 24? Notice I'm not really concerned with the negative right now. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay. Those are the factor pairs of 24. Step 3, identify the factor pair that adds to B. Or in this case, we can even subtract to form B. Truthfully, we may have to change the signs, and that's what that means. We may have to actually end up subtracting. So in this case, B is -10. Okay, it's the coefficient of x. It's our linear coefficient. All right, so which of these factor pairs up here can we add or subtract and get -10? Okay. Now I could change signs. So let's think about this. And this is where knowing that maybe we should keep that -24. So for example, 12 and -2. Or sorry, 12 and 2. If I subtract 12 from -2, or I add +2 and -12, I'll get my -10. Okay. Now you may be looking at, but what about 4 and 6? 4 and 6 is 10, and -4 plus -6 is 10. Sorry, -10. Ooh. But if I multiply those together, I get +24, which we want -24. Okay, so be careful with that. So the pair that I want to use will be 2 and -12. They multiply together, give me -24, but add together and give me -10. All right, so now we're going to split this linear term up. Okay. In other words, I'm going to split that -10x. So, for example, I'm going to take 3x squared minus 10x minus 8. We want to split that up. 3x squared plus 2x minus 12x minus 8. Okay, where this is still our -10x. Okay. Now we have 4 terms. So we can factor this by grouping. Shoot. That was supposed to go here somehow, but it is. Okay. Sorry about that. Okay. But we want to factor that by grouping. We want to factor 3x squared plus 2x minus 12x minus 8 by grouping. Well, if you recall from 9.5, the common factor between 3x squared and 2x, okay, so that's our first group, is x, so I can factor out an x. And what's left? 3x plus 2. with the negative 12x and an 8, the biggest number, or in this case, all the factors, since they're both negative, I can factor out a negative. And then between 12 and 8, I can factor out a 4. So we can factor out a negative 4. And what's left? Well, if I take negative 12 and divide it by negative 4, I get positive 3x. And if I take negative 8 and divide it by negative 4, factor out that negative 4, I'm left with a positive 2. And you'll notice that each factor, okay, each term now has a factor of 3x plus 2. So what's inside the parentheses? 3x plus 2. That's one factor. And the other factor is everything outside of the parentheses. Okay, x minus 4. And that's how you factor. Okay, that was a lot at once. Okay, I'm taking it slow, but it's actually kind of quick once you get the hang of it. So let's go ahead and do number 4. Okay, we're going to factor this polynomial and verify by multiplying. Okay, so first step, we're going to multiply a and c. This is often called the AC method of factoring, but really it's just factoring. All right, so AC equals 10. We're going to list the factors of 10. 1 and 10. 1 times 10 and 2 times 5. Those are all the factors of 10. We're going to identify the factors of 10 that add to 11. Okay, I always think in terms of addition first. And 1 plus 10 is 11. So I'm going to break this up. We got 2v squared plus 1v plus 10v plus 5. Now, one question that you may be wondering is, does it matter which order I write this 1v plus 10v? And the answer is no. It doesn't matter. Just roll with it. Okay, whichever way you do it, there will be a common factor. If there's not, then you probably picked the wrong common factors, or you picked the wrong factor pairs, or it's not factorable, and that can happen sometimes. So 2v squared plus 1v plus 10v plus 5. We have common factors between 2v and 2v squared plus 1v. We have common factors. And that would be v, right? They each have a factor of v, so I can factor that out, leaving 2v and 1. Over here, with 10v and 5, they each have a common factor of 5. So I can factor out a positive 5. Leaving, well, if I take 10v divided by 5, I'm left with 2v. If I take 5 and divide it by 5, I get 1. So what's in the parentheses? 2v plus 1. And everything outside the parentheses, v plus 5. Okay? And it's worth noting that these are all equivalent. Okay? We haven't done anything to change the value of this expression. They're each equal to each other. Okay? Different steps of the process. So, go ahead and try number 5. And I'll give you some time before I show you the 5 through 10. Go ahead and do those. And I will give you some time to work on that before I show you the solutions. All right, so here's the solution for number 5. Okay, again, you want to start out with multiplying a times c, getting that negative 100, and then find those factor pairs, okay? That's good practice. I mean, some of you might look at negative 15 and jump straight to it, but it is good practice to list those factor pairs. And again, I told you this in 9.5, be systematic about finding those factor pairs, okay? Don't just start with the first one. Start with 1. 1 times this, because sometimes 1 is the answer, okay? Move on to 2. Okay, I tried 3. 3 doesn't go into 100. So then I moved on to 4. 4 times 25, 5 times 20, 10 times 10. And when you get to the point where it's like the same number or adjacent numbers, so like 5 times 6 in the case of doing factors of 30. Okay, that's how you know I'm done. Okay, I can't go any further, can't go any higher than 10 because I've already covered everything past 10. All right, so find those factor pairs and then look for the factor pair that adds up to that middle term or subtracts. Okay, so I couldn't find a pair that added to 15, so I switched to subtraction. What do I need to subtract to get 15? All right, negative 15. And 20 and 5 stood out. Okay, I know 20 minus 5 is 15. So then let me switch that around. Let me do 5 minus 20, or positive 5 plus negative 20, or positive 5 minus 20. All right, so that's, I would say, step 2. Step 3, split it. Step 4, factor by grouping. And then, you can verify by multiplying. And as you can see, okay, using the box method, we end up back where we started. And there's that beautiful split that we did, okay? So I think that's an excellent way to work that out. Now, there's a way to factor using the box method. You may want to look into that. But for this lesson in particular, I'm showing you this method of factoring, okay? All right, so I'm going to show you the solutions to number 6. So if you want to pause and work out number 6, go ahead and do that now. And here's the solution for number 6. Okay, again, find AC. Get those factor pairs listed out. Find that pair that adds up to that middle term. Okay. I know I want to multiply together and get negative 6. And the only way we get a negative is with opposite signs. Sorry, multiply and get negative 36. The only way we multiply together and get negative numbers is if one's negative and one's positive. Those numbers are negative and positive. So we have to find opposite signs anyway. So I just list the factor pairs and then say, okay, well, which of these is going to get me to 5? And then I worry about the signs. All right, so next up, the answer to number 7. All right, so we're actually going to modify number 9. So go ahead and change number 9 to 18x squared plus 51x plus 15. All right, now back to number 7. All right, so number 7. There was a greatest common factor, which was 4. So I factored that out. That left me with 3e squared minus ae plus 3. So then from there, find AC. 3 times 3 is 9. Listing all the factors of 9. 1 times 9, 3 times 3. Which of those pairs can I get a negative 8? Okay, we're shooting for a negative 8. And instantly I think of, well, I know 1 minus 9 is negative 8, right? Cool. But is 1 times negative 9, 9? And the answer is 9. That's German for no. Okay, so 1 times negative 9 is negative 9, not positive 9. So I can't find factors of 9 that add up to negative 8. which means I cannot factor this. So then we're done. We just can't factor. It is as it's unfactorable. And we'll look at how to take this concept further once we get the quadratic functions. But for right now, that's all we can say is we can't factor it. So buckle up for number 8. If you haven't worked it out, go ahead and pause it. If you have, I'll show you the solutions in a bit. All right, so here's a solution for number 8. This one, I would say, be careful. We look for the greatest common factor, and when comparing numbers, we say, negatives are less than positives, right? But in this case, we want to factor out really all common factors, and that's what a GCF is. It's all common factors. So between negative 9y and negative 9, yes, 9 is the literal greatest common factor, but that leaves a factor of negative 1, which is also a common factor. So we want to factor that out as well. So we want to make sure we're factoring out a negative 9 from not negative 9y minus 9. And we want to factor out that negative 9. Okay. All right, so this is becoming a long video, so I want to wrap this up. Here's a solution for number 9. Be careful when giving the answer, okay? 3 is still part of that factorization. We can't just discount it because we factored it out at the very beginning. You want to include that factor of 3, okay? But there's a solution. If there's any questions about this problem, we can address that when I get back to class on Thursday after your quiz. By the way, there is a quiz. It's a 1-question quiz. It will look something very similar to number 9, okay, where there is a greatest common factor to factor out, and then from there you can factor by grouping, okay? So that is the whole goal of today, is for you to learn how to do this. So I'm going to quiz you on that on Thursday. Forgot to mention that yesterday. Surprise, surprise. All right, number 10, here's the solution. Here's the solution to number 10. And again, you have a quiz tomorrow. It is on factoring quadratic trinomials. And I know number 10 isn't a quadratic trinomial, but there was a greatest common factor of 5w. So once you factor that out, that left you with a quadratic trinomial, the 2w squared plus 3w minus 9, and that could be factored. So you just factor that piece. Now remember, everything is being multiplied together in your solution. So it should look like this. Okay. You could swap the factors in parentheses. So if you did 5w times 2w minus 3 times w plus 3, okay, swap those parentheses around, that's fine too. But generally, we're not going to put the 5w between a set of parentheses. Or you could put it at the end, but that also kind of looks funky. So there you go. If there are any questions about this factoring, you can ask me that during SOAR, or before the quiz. I'll give you guys probably about 5-10 minutes tops before I expect you to start that quiz. Good luck.